Welcome to Sundar's lecture. This is lecture number 86, and in this lecture we are going to see what is the relation between Z parameter and Y parameter. Let us we say this is Z matrix and Y matrix, both are same, and also we are going to see what is H parameter and then what is A, B, C, D parameters, right? We have already seen what is Z parameter and Y parameter, and we have concluded this one, right? This is the Z parameter and this is the Y parameter, and also we have told that if you bring this Z parameter to the other side, then it becomes inverse, right? Then that is nothing but this expression. So the inverse of Z parameter can be written as Y parameter, right? So right now we will see what are all the complications there if you want to say that the Z matrix can be the inverse of Y matrix. It is not possible in all cases. And what are all those cases? And the example for those cases we are going to see in this particular lecture, right? So that is the thing. So for example, if this is the Z parameter, let us consider this is the Z parameter, maybe Z matrix. Then if you want to find what is Y, then Y should be is equal to, how will you take the inverse of 2 cross 2 matrix? What is the procedure? So this will be 1 divided by Z11 into Z22 minus of Z21 into Z12, right? This multiplication minus this multiplication, right? So this will be the term, and then you will have the matrix value of, this will be inversed, so it will be Z22 and it will be Z11, and these two signs should be replaced. Signs of these two matrix should be replaced, right? So this is what we have seen in the, this is what the procedure to take the inverse of a matrix. For example, if in case this value, maybe I will write it down, this value Z11 multiplication of Z22 minus Z21 multiplication of Z12 becomes 0. For example, if it becomes 0, then what happens? 1 by 0 value will make this matrix to be infinity. Can you understand? Then if it is so, then Y matrix will become infinity because you have to multiply all the terms with this particular constant value. So what happens? Then Y matrix becomes infinity. So that is the only case. So obviously this multiplication should not become 0. If it is so, there will be some cases that this matrix becomes, this value becomes 0 2, right? So that is what we are going to take an example, and we are going to review that in what are all those cases where we cannot say that Z parameter can be the inverse of Y parameter, right? That is what we are going to see. One thing we have made a mistake, not a mistake, maybe I have told you that I will take the current direction in this way. Sorry to say that we should not take in this direction, it has to be opposite direction. In all the cases you change that because we have not solved any problem, so we cannot what are the expressions we have derived in the previous class will not affect the current direction anyhow, but you change the current direction wherever you see it has to be like this. I have just taken the direction opposite in the last class, so you just change this. So hereafter I will use this direction in the opposite way, right? So now let us take an example, right? Example, I will draw the diagram and I will show you, right? Now you see this is the example now, and in this example this particular network is the 2-port network, and we are giving input, the input port voltage is V1 and the current is I1, and the second port voltage is V2 and the current direction is I2, right? Now if you try to write the Z parameter for this one, what is the Z parameter? It is V1. Let it be, I will write it down the expression. V1 should be is equal to Z11 I1 plus Z12 I2, right? Z12 I2, and then V2, which is equal to Z21 I1 plus Z22 Z22 I2, right? This is the expression. And how will you find Z11? Let me find Z11. What is the formula to find Z11? Z11, which is equal to V1 by I1. This is what we have seen in the previous class. At the rate of I2 should become 0. I2 should become 0, right? Am I right? Is that 1 and then I2 should become 0, right? Now what you do, if you want to do this, then this has to be open circuited. This has to be open circuited. That is so that the I2 current becomes 0, right? And you have to apply a voltage here. For example, the diagram will looks like this. So this will be the diagram we will have like this, right? This is the diagram. This is plus minus V1 and this is the current I1 and this is the current I2. If you want to make the current I2, then this has to be open circuited, right? This has to be open circuited. If this has to be open circuited, then there will not be any current, right? There will not be any current. So I1 also what? It becomes 0. Try to understand. I1, what happens to I1? I1 will be also becomes 0 here. So what is the value you will get here? Z11, it's going to be infinity because I1 is 0. So what is the value of Z11? Z11 become infinity here. So there is no possibility for Z matrix if for this circuit. So maybe if you are going for any other thing, everything in all other expressions, the whole Z matrix becomes infinity. The whole Z matrix become infinity. You try to solve this problem by whatever the procedure we have seen in the previous class. Anyhow, you will get the values to be infinity, right? Now what you do, we try to get the Y matrix for this particular circuit. Then let us see what happens to the Y matrix, right? Right now we have taken the circuit. Let us rewrite the Y matrix equation. What is the Y matrix equation? It is I1 should be is equal to Y11 and then it is V1 plus Y12, it will be V2 and then I2 can be written as Y21 V1 plus Y22 V2, right? This is the expression. And if you want to find what is Y11, then what is the procedure? Y11 can be written as this value. It is I1 divided by V1, I1 divided by V1 at what you have to do? You have to make V2 to be 0. You have to make the V2 to be 0. So what happens now? What happens? So if I take this, then if you make the circuit, then it will be like this will be like this. So you will apply V1 here, and you need to short circuit this one. So what happens here? So this is I1 and this is Ez now, and maybe this is V1 plus minus V1 and I2 will flow now. I2 will flow, right? What happens here? The V2 becomes now 0, right? That is the one way. So what will be the value of I1 by V1? What is the I1 by V1 here? Obviously it will be Z, right? It will be V1 by I1. Here you will get what? What is the value of Y11 will be is equal to I1 by V1, it will be 1 by Z, right? That is the whole idea. If you write the equation, maybe I will write it down here. Write the KVL expression, what you will get. So V1 plus V1 minus I1 into Z. Maybe you leave this current because I1 which is nothing but what here, it is minus I2. So will be equal, minus V2 will be equal to 0, right? That is the equation. So V1 will become now I1 and Ez, and this V2 is 0 here, obviously it becomes 0. So what happens to Ez? It will be V1 by I1. So what is this expression now? It is the inverse of Ez value. It is the inverse of Ez value. So you got the value, right? Ez Y11 You got it, right? This is the value of y11. So likewise, and also you can find the value of y21, right? So what will be y21? So maybe I will write it in a different color. So y21 can be also written as I2 divided by V1, right? I2 divided by V1. What is I2? I2 is minus I1, right? So this value will be minus I1 by V1. Then what will be the value of Y21? Then Y21 will become now minus 1 by Z. That's all. Very simple, right? Very simple. You can easily find the values once you know the procedure. Once you know the procedure. So Y11 and Y21, you got the values. And if you want to find the values of y22 and y12, then you have to make the v1 to be 0. So if you make v1 to be 0, then you short circuit this and give the voltage across this path. And now what happens? So you will again get the values. You will again get the values. So I will directly write those kind of values. I am not going to do that. You will get y12 will be is equal to minus 1 by z. Y12 is equal to minus 1 by z, and you will get y22 will be is equal to 1 by z. This will be the value you will get once you solve the problem. I'm not going to solve. You just put V2 here and you short circuit V1, so V1 becomes 0, and write down the expression, and you will get the expression like this. So now if I consolidate this, what I will get, see, I will write it down here. So Y matrix, I am getting it as 1 by Z minus 1 by Z minus 1 by Z 1 by Z. This is the Y matrix I am getting from for this particular circuit. Right? So now, if I want to, this is Y matrix. Maybe if you are writing it as matrix form, then I1, this is I2, and this matrix will be like this: 1 by Z minus 1 by Z. This is minus 1 by Z. It is 1 by Z into V1, V2. Right? This is the matrix or Y parameter we are getting. Now, if you want to find Ez parameter for this, so how will you find Ez parameter? You have to take the inverse of this matrix, right? How will you take the inverse of this matrix? So this will become 1 divided by, you have to multiply these two, 1 by Ez into 1 by Ez. That will be the value minus of, then you have to multiply these two, minus 1 by Ez into minus 1 by Z, right? This is what you will get, right? Can you understand? Try to understand. And then this value, you have to inverse these two. 1 by Z will be there and 1 by Z will be there, and this value will, you have to reverse the sign, 1 by Z and 1 by Z. Now you see these both are same, right? Because minus into minus become plus, and 1 by Z square minus 1 by Z square will become what? 0. See, so this is the conclusion. So Z matrix becomes infinity for this circuit. So for this two-port network, you have Y matrix, you can find the values of Y matrix, but you cannot find the values of Z matrix. This is what I have told you in beginning. See, for some circuits you will have Y matrix, for some circuits you will have Z matrix, right? So we will take another example and we try to see, for another circuit you can have a Z matrix, but Y matrix will become infinity. That I will draw the diagram. Right. Now you see we have taken a circuit like this, and this is the first port or input port V1, and the current is in this direction, and this is V2 and the current is in this direction. This is output port. Now this is the circuit. This is two port network, right? Now if you want to find what is the Z parameter for this particular circuit, what will you do? So V1 can be written as Z11 I1 plus Z12 I2, and this is the equation. And if you are going for V2, then it will be Z21 I1 plus Z22, and then it will be I2, right? So now maybe it is very simple circuit, so you don't need to open circuit, short circuit, and do so many things to get the values, right? It is very simple. See what we will do, we try to write the KVL for this particular loop. This is a loop, right? If you apply voltage here, then this becomes a loop. This becomes a loop. Make this circuit open circuited, and you don't apply anything here. Let it be the open circuit. Then if you are writing the KVL expression for this particular loop, you just apply V1 only. So what will be the V1? So if your current is in this direction, so V1, and then the current is going in the same direction as I am going, so it will be minus of I1 plus I2 into Z will be equal to 0. So what you will get? So V1 will be is equal to I1 Z plus I2 Z. Make this as expression number 1. Take this as expression number 1. And what maybe I will write it down here. Apply V1 and open circuit port 2, second port, right? And now what I will do, apply V2 and open circuit port 1. You just open circuit the port 1. So I will apply here. So I can write the KVL expression for this particular loop. So what I will get, so current is in this direction, so it will be plus V2, and then the same direction I'm going, so it will be I minus I1 plus I2 into Z, and that should be is equal to 0. So if you are writing for V2, so V2 can be written as, if you bring this to other side, what you will get, it will be I1 EZ plus I2 EZ. Make this as expression number 2, and you see this is V1 expression and this is V2 expression, and what is this one? This is Z11, and what is this one? This is Z12, and what is this value? What is this one? Z21, and this value, it will be Z22, right? So if you are writing the expression, what you will get, so this is V1, maybe this is V1, and this is V2, and equal to, this will be Z, this will be Z, this will be Z, and this will be also Z into V1, sorry, I1, and then this will be I2, right? So this is the Y parameter. Maybe this is the sorry, not Y parameter. This is the Z parameter, and this is the Z matrix. Now, if you want to find Y parameter, then if you need to get what is the Y matrix, right? So Y matrix will be, now what you will get, for an obvious reason, it will be Z square minus, this will be also Z square, then this value will be reversed, and the sign of these two should be changed. This is the inverse. And what happens to inverse? What happens to inverse? It is 1 by 0. Then obviously Y matrix become infinity. Right? That is what we have seen here. And you have to conclude that for this particular circuit, Z matrix exists. Z matrix exists. But what happens to Y matrix? Becomes infinity. Right? Am I right? So now, and then if we are going for this particular network, here Y matrix exists for this circuit, Y matrix exists, and what happens to Z matrix? It becomes infinity, right? Can you understand? Can you understand what I am saying? So the conclusion is, we have taken two different examples, one for which Y matrix exists and one for which Z matrix exists. So the conclusion is very simple, that it is not always that a Y matrix can be a inverse of Z matrix and a Z matrix can be a inverse of Y matrix. There is a condition where in certain circuits you cannot see that Y matrix can be an equivalent to inverse of Z matrix. That is the two different examples, and you need to see that the multiplication of these two terms minus of these two terms should not become 0, and if it is so, then there will not be, the one matrix will not exist, right? So we will conclude with this with this topic in this lecture, and in the next lecture we will see what is H parameter and ABCD parameter, and we will see a new two different parameters in the next class. You go through this and we will see in the next class. Thank you.